January 29, 1943, Guadalcanal, 14,000 feet above the Solomon Islands. The Mitsubishi A6M20's cockpit glass reflected the afternoon sun as Lieutenant Commander Saburo Sakai, Japan's third-ranking ace with 64 confirmed kills, watched the strange new American fighter climbing toward his formation through the crystal-clear Pacific sky. The aircraft appeared grotesque to his experienced eye, its massive radial engine creating an ungainly profile that seemed to defy the elegant aerodynamic principles Japanese designers favored. Most striking were the inverted gull wings bending downward from the fuselage before angling sharply upward toward the tips, giving the fighter the appearance of a wounded seabird struggling skyward, all wrong angles and awkward proportions that violated everything Sakai had learned about fighter design in 12 years of naval aviation. Through his gun sight, Sakai studied the approaching fighters with the confident analytical eye of a veteran who had dominated Pacific skies since the attack on Pearl Harbor 14 months earlier. The Americans flew in 2 divisions of 6 aircraft each, 12 fighters total, climbing steadily toward the Japanese formation with what appeared to be labored effort. Their rate of climb seemed unimpressive, their formation discipline adequate but unexceptional. Nothing about their appearance suggested they represented any significant threat to Japanese air superiority that had been absolute since December 1941. Beside him, flying perfect wing position at precisely 150 meters, Petty Officer First Class Nishizawa Hiroyoshi keyed his radio transmitter. They moved slowly, Nishizawa observed with the casual contempt of a pilot who had shot down 87 Allied aircraft in 2 years of continuous combat. Heavy and slow, like all American machines. No spirit, no warrior's heart, just metal and fear. Sakai smiled behind his oxygen mask, though Nishizawa's assessment troubled him slightly. Intelligence reports from the Rabaul headquarters had mentioned a new American carrier fighter entering service, something designated F4U by the Americans. The reports contained conflicting information. Some claimed the aircraft was too dangerous for carrier operations, suggesting poor handling characteristics. Others mentioned impressive speed and firepower that exceeded previous American fighters. The contradiction left Sakai uncertain. But looking at the ungainly silhouettes climbing toward his formation, he found it difficult to imagine these machines posing any serious challenge. This must be the new carrier fighter American propaganda boasted about, Sakai transmitted to his wingman and the rest of the formation, unable to suppress his amusement at the lumbering silhouettes approaching from below. They send us targets shaped like flying whales. Observe how they struggle to reach our altitude. We will feast on them like sharks among schooling fish. The radio frequency erupted with laughter from the 18-0 pilots circling at 16,000 feet. These were not novice pilots, but battle-hardened veterans from the 582nd Air Group, men who had flown combat missions since the invasion of China in 1937. They had destroyed Brewster Buffaloes over Burma in early 1942, shot down Wildcats throughout the Solomon Islands campaign, and achieved kill ratios that averaged 7-1 against American opposition. What Sakai didn't know, what none of the Japanese pilots circling above Guadalcanal could have imagined as they prepared to pounce on what appeared to be easy prey, was that they were witnessing the arrival of the weapon that would systematically destroy Japanese naval aviation as an effective fighting force. Within 18 months, this supposedly ungainly aircraft, with its awkward bent wings, would achieve an 11-1 kill ratio against the legendary Zero, rendering obsolete every tactical doctrine Japanese pilots had developed. Its 650 caliber Browning machine guns, firing in synchronized convergence, would become the most feared sound in Pacific skies, delivering 1,200 rounds per minute of armor-piercing incendiary ammunition that could saw a Zero in half with a 2-second burst. And Japanese pilots who survived encounters with this aircraft would come to call it Whistling Death, a name born not from military respect, but from visceral terror of the distinctive sound those wings made during high-speed dives, a whistle that became audible warning of incoming annihilation. The transformation from mockery to dread would be written in the statistics of aerial combat and sealed in the testimony of survivors who learned too late what those 6 machine guns could do when properly employed. 1,500 combat sorties, 2,216 enemy aircraft destroyed, 64,000 individual missions flown, and a combat loss rate of 0.7%. These numbers would make the F4U Corsair the most successful fighter in naval aviation history. But on that January afternoon in 1943, as Major Gregory Boyington led 12 Corsairs of VMF 214 toward their first engagement with Japanese forces, the enemy pilots saw only another American fighter to add to their victory tallies. The Japanese confidence that January morning wasn't arrogance but experience validated through 2 years of unbroken aerial dominance. Since the Pearl Harbor attack on December 7, 1941, Japanese naval aviation had achieved victory after victory across the entire Pacific theater. The Mitsubishi A6M0 had proven itself the most capable carrier fighter in the world, combining exceptional range, maneuverability, and adequate firepower into a package no Allied fighter could match in turning combat. British pilots flying Hurricanes and Brewster Buffaloes had learned this lesson painfully over Singapore and Burma during early 1942. American pilots in Wildcats had discovered it during the desperate battles of Coral Sea and Midway, where Japanese numerical superiority combined with pilot skill to achieve dominance despite strategic setbacks. By January 1943, the Zero's reputation bordered on mythical status. Pilots from Germany's Luftwaffe, reviewing intelligence reports from their Japanese allies, expressed skepticism that any single-engine fighter could achieve such extraordinary performance characteristics. Yet the numbers didn't lie. Japanese fighter pilots had achieved kill ratios averaging 5-to-1 across all Pacific theaters, reaching as high as 12-to-1 in specific engagements where veteran pilots engaged inexperienced American opposition flying inferior equipment. The Zero's dominance stemmed from design philosophy that prioritized specific capabilities over others in ways that perfectly matched Pacific naval warfare requirements. Chief designer Jiro Horikoshi had created an aircraft optimized for carrier operations across vast ocean distances. Range exceeded 1,900 miles with external drop tanks, allowing operations from carriers positioned far from combat zones where American submarines and patrol aircraft threatened Japanese fleet operations. Wing loading, the ratio of aircraft weight to wing area, was extraordinarily low at 21.8 pounds per square foot, giving the Zero turning performance that was literally unmatched by any contemporary fighter anywhere in the world. Rate of roll was exceptional for the era. Time to complete a full 360-degree roll at typical combat speeds was less than 5 seconds. Maximum rate of turn at optimal speed generated forces exceeding 6 Gs, far beyond what most Allied fighters could sustain without stalling. These characteristics made the Zero nearly impossible to escape once it locked onto a target in a turning fight. American pilots who survived early encounters filed consistent reports stating that attempting to turn with Zeros was suicidal. The Japanese fighters could complete 2 full turns, while Wildcats managed barely 1.5. Japanese pilot training, legendary throughout military aviation for its rigor and high standards, transformed these exceptional aircraft capabilities into devastating tactical superiority that seemed almost supernatural to Allied opponents. The selection process began with physical examinations so demanding that they eliminated 90% of applicants before flight training even began. Candidates needed perfect eyesight, excellent physical coordination, exceptional reflexes, and psychological profiles indicating aggression balanced with discipline. Those who passed initial screening underwent 3 years of intensive training that included not just flying, but comprehensive instruction in navigation, gunnery, aerobatics, formation flying, tactical doctrine, aircraft recognition, survival skills, and the spiritual discipline central to Japanese military culture. By the time a pilot earned his wings and qualified for carrier operations, he had accumulated over 700 flight hours, more than double what American or British pilots received and triple what Soviet pilots got. Senior petty officers like Sakai and Nishizawa possessed over 2,000 flight hours accumulated through years of continuous operations. This experience translated directly into combat effectiveness that seemed almost superhuman. Japanese pilots could exploit their aircraft's advantages with precision that defied Allied understanding. They understood exactly when to turn, when to climb, when to dive, when to disengage. They could judge deflection angles instinctively, placing bullets where the target would be rather than where it was at the moment they squeezed the trigger, and they fought with aggressive spirit that never wavered, even when outnumbered or facing apparently superior opponents. The story of how this Japanese dominance would be systematically destroyed begins not with Pearl Harbor's triumph, but with an engineering problem that nearly killed the Corsair program before the first production aircraft reached combat squadrons. In February 1938, 5 years before Sakai would encounter Corsairs above Guadalcanal, the United States Navy Bureau of Aeronautics issued a specification for a new carrier-based fighter that seemed to contradict basic aeronautical engineering principles. The requirement document demanded maximum speed of 400 miles per hour at 15,000 feet, which was 50 miles per hour faster than any existing fighter could achieve. It specified armament of at least 4 machine guns with sufficient ammunition capacity for sustained combat engagements lasting several minutes. It required range of 1,000 miles minimum to enable offensive operations far from carrier task forces. And crucially, it insisted on the ability to operate from existing aircraft carriers with their limited deck space, weak catapults, and primitive arresting gear systems. Every major aviation company that received these specifications understood immediately the fundamental problem embedded in these contradictory requirements. To achieve 400 miles per hour speed in 1938 required the most powerful aircraft engine available in the United States, which was the Pratt & Whitney R2800 Double Wasp, an 18-cylinder twin-row radial producing 2,000 horsepower at maximum power settings. This engine represented cutting-edge technology, more powerful than engines fitted to most contemporary bombers. But that massive power plant, with its enormous displacement of 2,800 cubic inches and dry weight exceeding 2,300 pounds, demanded a propeller at least 13 feet in diameter to convert horsepower into thrust with acceptable efficiency. Smaller propellers would cavitate, losing efficiency and creating noise that would deafen pilots. The engineering problem crystallized around simple geometric constraints that seemed unsolvable. To provide the necessary 18 inches minimum propeller tip clearance from the carrier deck during takeoff, accounting for the tail-down attitude during catapult launch, and the propeller's rotation through a complete circle, the landing gear would need to be at least 8 feet tall from axle centerline to wing attachment point. Landing gear 8 feet tall presented an unsolvable structural problem, using materials and engineering techniques available in 1938. To withstand the violent forces of carrier landings, where 5-ton aircraft slammed onto decks at speeds exceeding 80 miles per hour, and then caught arresting wires that applied 9G deceleration forces, the gear legs needed to be massively strong with heavy structural bracing. But tall landing gear was inherently weak from a structural mechanics perspective. The longer the strut, the greater the bending moment at the attachment point during side loads from crosswind landings or asymmetric touchdown. This required progressively heavier structure as gear height increased. But heavier landing gear added weight that reduced performance, particularly rate of climb and maximum speed, which negated the entire purpose of installing the powerful R2-800 engine in the first place. Engineers at Curtiss, Grumman and Brewster all explored various solutions: retractable landing gear that folded forward into the engine cowling, telescoping gear that extended hydraulically during takeoff and landing, unconventional undercarriage arrangements that moved the wheels far outboard to allow shorter struts. None proved practical given weight, complexity, and reliability constraints. The Navy specifications seemed to demand an aircraft that physically couldn't exist given the constraints of materials science, structural engineering, and aerodynamics available in 1938. Chancevort's chief engineer, Rex Beisel, found the solution not through conventional thinking but by challenging the fundamental assumption underlying everyone else's analysis. The problem wasn't that the landing gear couldn't be tall enough. The problem was that everyone assumed wings had to be horizontal and straight. If the landing gear couldn't be tall enough for a standard wing configuration, Beisel reasoned, perhaps the wings themselves could be positioned lower relative to the propeller arc. But simply lowering straight wings created other insurmountable problems. The fuselage needed to be high enough to provide propeller clearance during ground operations, while the wings needed to meet the fuselage at points that allowed proper structural load distribution during high-G maneuvers. Moving the wing lower on the fuselage created a high wing configuration that was structurally inefficient and aerodynamically problematic. Beisel's breakthrough came in March 1938, when he abandoned conventional thinking entirely and sketched an inverted gull wing configuration. Instead of straight wings meeting the fuselage at a constant height, his design featured wing roots that angled sharply downward from the fuselage attachment points before bending upward toward the wingtips. This created a distinctive M shape when viewed from directly ahead. The downward angled center section placed the main landing gear attachment points significantly lower on the aircraft structure, reducing the required leg length from an impossible 8 feet to a manageable 5.5 feet. This length was short enough that the gear could be made structurally strong without excessive weight penalty while still providing adequate propeller clearance. The solution was elegant, innovative, and completely unconventional. But it worked brilliantly on paper, solving the seemingly unsolvable problem that had stopped every other design team. The inverted gull wing solved the propeller clearance problem, but created new challenges that would plague the Corsair throughout its development and nearly kill the program multiple times. The wing root bend generated complex three-dimensional airflow patterns that were poorly understood in 1938. During the transition from straight and level flight to high angles of attack during landing approaches, these flow patterns caused the wing to stall suddenly and without the progressive buffeting that normally warned pilots of impending stall. The aircraft would be flying normally one moment, then dropping toward the ground the next with no warning. This characteristic terrified even experienced test pilots and would kill numerous trainee pilots during the rushed wartime training programs. The long nose required to house the massive R2800 engine, with all its accessories, oil cooling system and ammunition bays, completely blocked forward visibility when the aircraft was in the tail-down attitude necessary for carrier landings. Pilots approaching the carrier couldn't see the landing signal officer, who gave critical commands about glide slope and lineup. They couldn't judge their height above the deck or their lateral position relative to the center line. They were essentially landing blind, trusting peripheral vision and instruments to avoid catastrophic accidents. The stiff landing gear, necessarily rigid to withstand the brutal forces of carrier operations, had minimal energy absorption characteristics. During hard touchdowns that would have been routine in aircraft with more compliant gear, the Corsair bounced violently back into the air, often entering a dangerous porpoising mode, where each successive bounce was worse than the previous one. This could damage the airframe, collapse the gear, or launch the aircraft back into flight at dangerously low speed and altitude. Despite these serious handling challenges that made the aircraft dangerous even for experienced pilots, the F4U prototype demonstrated performance that exceeded every prediction, specification requirement, and contemporary aircraft benchmark. First flown on May 29, 1940 by Lyman A. Bullard Jr., Vort's chief test pilot and one of America's most experienced aviators, the prototype achieved remarkable results during its initial test flights from the company airfield in Stratford, Connecticut. Level flight speed at 15,000 feet reached 405 miles per hour, making it the first American fighter to exceed 400 miles per hour in level flight, and establishing it as the fastest aircraft in the world at that altitude. This was 70 miles per hour faster than the Zero could achieve, and 50 miles per hour faster than Germany's best fighters. Rate of climb exceeded 3,000 feet per minute at sea level, allowing the aircraft to reach 20,000 feet in less than 7 minutes. Service ceiling approached 37,000 feet, higher than most contemporary fighters could even reach. Range with internal fuel alone exceeded 1,000 miles, meeting the Navy's requirement without external tanks. The armament installation of 650 caliber Browning M2 machine guns with 400 rounds per gun delivered firepower that exceeded any existing fighter by a factor of 2 or more. Every specification requirement had been met or exceeded by substantial margins. The Navy, recognizing they possessed a potentially war-winning weapon despite its handling difficulties, awarded Chance Vought a production contract for 584 aircraft in June 1941, 6 months before Pearl Harbor would transform theoretical requirements into desperate operational necessities. But bringing the Corsair from successful prototype to combat-ready production aircraft would prove far more challenging than anyone anticipated. Production aircraft accumulated weight as combat equipment was added. Radios, oxygen systems, armor plate, self-sealing fuel tanks, and operational equipment added over 800 pounds to the prototype's empty weight. This weight gain degraded performance, particularly climb rate and acceleration. Early production aircraft handling characteristics were even worse than the prototype. The stall was more abrupt, the forward visibility even more restricted, the landing bounce tendency more pronounced. Between October 1942, when the first production F4U-1S reached operational squadrons, and April 1943, when handling improvements were finally implemented, training accidents killed over 30 pilots. This was 3 times the accident rate of comparable fighters. Every accident generated reports that circulated through Navy Bureau of Aeronautics, reinforcing growing concerns about the Corsair's suitability for carrier operations. By December 1942, as reports of handling difficulties accumulated on his desk, Rear Admiral John McCain, Chief of the Bureau of Aeronautics, ordered a comprehensive evaluation of the F4U's carrier suitability. Captain Frederick Trapnell, the Navy's most experienced test pilot and the officer responsible for tactical aircraft development, conducted exhaustive carrier landing trials aboard USS Charger in Chesapeake Bay during bitterly cold January weather. Trapnell, who had over 5,000 flight hours and had tested every Navy fighter since 1935, filed a brutally honest evaluation report in February 1943 that would change the Corsair's destiny. The visibility problems during carrier approaches are unacceptable and cannot be adequately compensated through technique, Trapnell wrote in clinical language. The stall characteristics are too dangerous for routine carrier operations, particularly at night or in adverse weather. The bounce tendency during touchdown is unpredictable and could result in deck crashes that damage multiple aircraft or injure deck crew. Trapnell's recommendation was unequivocal. The F4U-1 is unsuitable for routine carrier operations without significant modifications to improve visibility and landing characteristics. Recommend relegation to land-based operations until engineering improvements correct these deficiencies. The Bureau of Aeronautics accepted Trapnell's devastating assessment, effectively removing the Corsair from consideration as a carrier fighter and designating it for Marine Corps land-based squadrons only. This decision, intended as a demotion that relegated the Navy's most advanced fighter to what many senior officers considered secondary missions supporting marine ground operations, would prove fortuitous in ways nobody could have anticipated. The Marine Corps, desperate for any modern fighter capable of matching Japanese capabilities, after suffering devastating losses in obsolete aircraft throughout 1942, embraced the Corsair enthusiastically, despite its demanding characteristics and dangerous reputation. Marine aviation operated from established land bases across the Pacific, with runways long enough that landing bounce wasn't catastrophic. They didn't need the difficult carrier landing capabilities that troubled the Navy. Marine pilots, though generally less experienced than their Navy counterparts in instrument flying and bad weather operations, proved highly adaptable and aggressively motivated. They were willing to master difficult aircraft if it gave them combat advantage over the Zero. Most importantly, Marine squadrons operating from rear area bases had time for the extensive training the Corsair demanded. Unlike Navy carrier squadrons that needed to maintain continuous operational readiness while rotating between combat deployments and brief stateside training periods, Marine squadrons could dedicate months to intensive F4U familiarization and tactics development before deploying to combat zones. This training time would prove absolutely decisive in the Corsair's eventual success. By February 1943, when VM F-124 under Major William Geese departed San Diego's Camp Kearney for deployment to Guadalcanal, their pilots had accumulated over 150 hours each in Corsairs. This was far beyond the 40 to 60 hours typical for fighter pilots transitioning to new aircraft types, and represented more training than most combat pilots received in their entire careers. The pilots understood the aircraft's quirks intimately. They respected its limitations and knew exactly how far they could push the envelope in various flight conditions. Most critically, they had learned through hundreds of practice engagements exactly how to exploit the Corsair's tremendous advantages in ways that negated the Zero's superior maneuverability. They had developed tactics, practiced them until they became instinctive, and arrived in the combat zone ready to employ the most capable fighter aircraft in the world. The armament that would make the Corsair legendary represented not just 6 guns but a carefully engineered weapon system that exceeded anything in Japanese or German aviation. The ANM 250 caliber Browning heavy machine gun, developed from John Browning's original water-cooled design from World War I, represented American ordnance engineering at its absolute finest. Each gun weighed 65 pounds and measured 65 inches in length. The installation in the Corsair's wings included electric solenoid firing mechanisms that provided more reliable ignition than mechanical systems, electrically driven belt feed motors that prevented jamming during negative G maneuvers when gravity would have interrupted mechanical feed systems, and pneumatic charging systems that allowed pilots to clear jams without manually cycling the action. The guns were mounted 3 to each wing in staggered installations just outboard of the landing gear attachment points, positioned so the recoil forces passed through primary wing spars for structural efficiency. Elaborate spent cartridge and link collection systems prevented ejected brass from damaging control surfaces or penetrating the wing skin. Heating elements wrapped around the gun barrels prevented the weapons from freezing at altitudes above 20,000 feet, where temperatures dropped to -40 degrees Fahrenheit. The ammunition load of 400 rounds per gun represented a carefully calculated balance between firepower duration and weight constraints. 400 rounds per gun meant 2,400 rounds total, weighing approximately 700 pounds with belts and links. At the ANM-2's cyclic rate of 750 to 800 rounds per minute per gun, which translated to a combined firing rate of 4,500 to 4,800 rounds per minute for all 6 guns, a pilot holding the trigger continuously could sustain fire for approximately 30 seconds. In practice, pilots fired in carefully controlled 2 to 3 second bursts that expended 300 to 400 rounds per burst. This provided enough ammunition for 6 to 8 separate firing opportunities per mission, allowing pilots to engage multiple targets or make multiple passes on difficult targets. The installation included a master armament switch on the throttle quadrant and a trigger button on the control stick grip that was positioned for easy access by the pilot's right index finger. The trigger design included a 2-stage mechanism. Light pressure armed the guns by energizing the firing circuits. Full pressure closed the firing circuits and initiated fire. This 2-stage system prevented accidental discharge while allowing experienced pilots to have the guns ready to fire the instant they achieved proper sight picture on a target. The 50 caliber Browning ammunition itself represented decades of development, creating what many experts consider the finest aircraft machine gun cartridge ever designed. Each complete cartridge measured 6.09 inches long and weighed approximately 4 ounces. The projectile alone weighed 0.71 ounces, approximately 45 grams, with a diameter of 0.51 inches. Muzzle velocity from the AN-M2's 36-inch barrel reached 2,900 feet per second, creating kinetic energy exceeding 12,000 foot-pounds per projectile. To put this in perspective, each bullet carried more kinetic energy than a .30-06 hunting rifle cartridge and could penetrate aircraft aluminum structure, steel armor plate up to half an inch thick, and continue traveling with lethal energy. The standard combat ammunition loading for Pacific operations mixed several projectile types in carefully calculated patterns designed to maximize combat effectiveness against various target components. Armor-piercing incendiary rounds featured hardened steel cores heat-treated to maximum hardness, surrounded by an incendiary compound that ignited upon impact. These rounds could penetrate aircraft armor plate, engine cylinder walls, and fuel tank structures before the incendiary compound ignited, setting fire to fuel, oil, and hydraulic systems. Armor-piercing incendiary tracer rounds provided identical penetration and incendiary capabilities while burning brightly due to a magnesium compound in the base of the projectile. This burning created a visible trail that allowed pilots to observe their fire and adjust their aim. The typical loading pattern for Pacific operations was 4 armor-piercing incendiary rounds, 1 tracer round repeated throughout the belt. This created a bullet stream that combined maximum penetration and incendiary effects with adequate trajectory visibility for aim correction. January 29, 1943. The engagement that would introduce Japanese pilots to the Corsair's overwhelming firepower superiority began at 14,300 feet above Guadalcanal, when Sakai's formation of 18 Zeros rolled into their planned attack dive on what appeared from their altitude advantage to be easy targets. The 12 American fighters below, identified by Sakai as the new F4U type based on their distinctive bent-wing silhouette, represented VMF-124 under the tactical command of First Lieutenant Kenneth Ambrose Walsh, a 26-year-old former enlisted pilot from Brooklyn, New York, who had accumulated over 2,000 flight hours through 10 years of naval aviation service. Walsh, who would eventually become the first Corsair ace with 21 confirmed victories and receive the Medal of Honor for his actions during subsequent missions, had spent the previous 12 hours studying the latest intelligence reports on Japanese tactics compiled by Marine Aviation Group 23's intelligence section. He knew exactly what the Zeros would attempt. They would use their altitude advantage to dive through the Corsair formation at maximum speed, make 1 or 2 quick firing passes targeting stragglers or aircraft in vulnerable positions, then zoom, climb back to altitude safety using energy gained during the dive. This was the standard Zero tactical doctrine that had proven effective against Wildcats throughout 1942, exploiting the Zero's excellent energy retention and climb performance to engage and disengage at will. But Walsh also knew something the Japanese pilots approaching from above didn't. The Corsair could dive faster than any Japanese fighter could possibly match, achieve higher sustained speeds in level flight than the Zero could reach even in emergency power settings, and climb better than the Zero at altitudes above 15,000 feet, where the R280's turbo supercharger maintained sea-level power while Japanese engines lost performance in thinner air. These performance advantages meant that properly trained Corsair pilots could dictate every aspect of engagement, choosing when to fight, where to fight, and when to disengage based purely on tactical circumstances rather than aircraft performance limitations. This was the ultimate expression of air superiority, the ability to force combat only when conditions favored your success. As Sakai's Zeros rolled inverted and dove toward the American formation, accelerating through maximum dive speed around 380 miles per hour, Walsh's division of 4 Corsairs responded instantly with a maneuver that would have been impossible in any previous American fighter. Rather than turning to meet the diving Zeros in the horizontal plane where Japanese maneuverability would provide advantage, or climbing to meet them where the Zero's better low-altitude climb performance would allow them to maintain energy advantage, the four Corsairs simply rolled inverted themselves and dove. But while the Zeros were diving at their maximum safe speed approaching 380 miles per hour, the Corsairs, with their massive R2800 engines at full emergency power, producing 2,250 horsepower with water methanol injection engaged, were accelerating through 420 miles per hour and still gaining speed. The Japanese pilots, committed to their attack run and unable to change direction without losing all their carefully accumulated energy, suddenly found themselves being overtaken from below and behind by American fighters moving 40 miles per hour faster than they were. In aerial combat, 40 miles per hour speed advantage translates to complete tactical control. The faster aircraft can close at will, can break off at will, can position itself anywhere relative to the slower aircraft, while the slower aircraft is helpless to respond. Walsh's after-action report, filed at Henderson Field's operations tent 3 hours after landing with his guns empty and his aircraft spattered with hydraulic fluid and aluminum fragments from destroyed Japanese fighters, captured the clinical precision of the one-sided engagement with language that would become characteristic of Corsair pilot combat reports. Observed 18 enemy fighters, identified as Zero type based on fixed landing gear and configuration, in standard attack formation, diving from approximately 16,000 feet toward our formation at 14,000 feet. I immediately executed emergency power dive to build maximum energy, reaching indicated airspeed 420 miles per hour before pulling up behind trailing element of enemy formation. Closure rate exceeded 100 miles per hour, allowing perfect positioning at optimal firing range. Opened fire at 350 yards range with 30-degree deflection angle on first target, Zero with green tail markings. Fired controlled 3-second burst, observed strikes walking from tail section forward along entire fuselage. Target aircraft exploded with violent detonation and immediate wing separation, likely indicating fuel tank ignition. No parachute observed. Continued attack run on second element without losing energy. Fired 2-second burst at second target at range 275 yards. Target's left wing structure failed catastrophically, separating at root and causing immediate uncontrolled spinning. Aircraft fell in multiple pieces. Executed maximum rate zoom climb to 20,000 feet without enemy pursuit, as remaining enemy aircraft scattered in defensive maneuvers. In less than 40 seconds of actual combat, Walsh's 4-plane division had destroyed 5 of Sakai's 18 Zeros without suffering even minor damage to any American aircraft. The engagement's completely lopsided outcome shocked both sides, though for entirely opposite reasons that reflected their completely different perspectives on what had just occurred. American pilots were thrilled and somewhat surprised to discover their new aircraft could so easily dominate the legendary Zero that had seemed invincible throughout 1942. They had expected the Corsair to be good based on its performance specifications, but the reality of combat revealed capabilities that exceeded even optimistic predictions. Japanese pilots, conversely, were horrified and deeply shaken to discover that their traditional tactics, proven effective through 2 years of continuous victories against every American fighter encountered previously, were completely ineffective and potentially suicidal against this new opponent. The surviving 13 Zeros scattered in all directions, abandoning all formation discipline as individual pilots sought safety through evasive maneuvers. But the Corsair's overwhelming speed advantage meant there was no safety in evasive flight. The American fighters simply selected targets of opportunity, dove to overtake them with speed the Zeros couldn't match, fired devastating bursts from convergence range, where all 6 guns intersected, then climbed away before the more maneuverable Japanese fighters could reverse direction and attempt counterattack. Petty Officer First Class Fujita Iozo, who had been flying wing position on squadron leader Miyano's right side when the engagement began, survived the carnage and filed a combat report within hours that would circulate through Japanese aviation command structure and reach Imperial Navy headquarters in Tokyo within 48 hours through normal intelligence channels. His account, written while his hands still shook from the experience and adrenaline still flooded his system, captured with painful clarity the shock of encountering an opponent that rendered Japanese tactical doctrine completely obsolete. The new American fighter designated F4U operates in ways completely different from the Wildcat or any opponent we have encountered. It does not attempt to turn with us where we possess decisive advantage due to our superior wing loading and power-to-weight ratio. It does not attempt to climb with us from low altitude where our engine performance is superior. It refuses every type of engagement where Japanese aircraft possess any advantage whatsoever. Instead, it dives from altitude at speeds we cannot match even in emergency power, attacks with overwhelming firepower from positions we cannot defend against, and climbs away faster than we can follow before we can bring our guns to bear. When its weapons fire, the destructive effect is beyond anything we have experienced from machine gun armament. I personally witnessed Lieutenant Commander Takeda's aircraft literally torn apart by concentrated fire, with the entire tail section separating cleanly and the forward fuselage breaking into multiple fragments. The pilot had no opportunity to escape. These weapons are not machine guns in the traditional sense, but something far more destructive. The Americans refuse to fight where we possess any advantage. They force combat exclusively in circumstances where they possess overwhelming superiority. Against such tactics executed with such overwhelming firepower and performance advantages, I do not know how we can achieve victory or even survive in acceptable numbers. This assessment, arriving at Combined Fleet Headquarters in Truk Atoll within 3 days through routine intelligence distribution channels, triggered the first serious institutional reconsideration of Japanese fighter doctrine and tactical assumptions since the Zero had established seemingly permanent air superiority in December 1941. But the Imperial Navy's senior leadership, steeped in 2 years of nearly unbroken victory and deeply invested in beliefs about Japanese warrior spirit compensating for material disadvantages, initially dismissed Fujita's report as defeatist exaggeration from a pilot whose spirit had been broken by his first encounter with a truly superior opponent. Vice Admiral Kakuta Kakuji, commanding the 3rd Fleet's aviation forces from his headquarters in Rabaul, wrote in his daily situation report that individual setbacks in isolated engagements did not indicate fundamental problems with Japanese tactics or equipment. Admiral Koga Minachi, who would assume command of the combined fleet following Admiral Yamamoto Isoroku's death in April 1943, agreed with this assessment. The institutional response reflected confidence born from unbroken success and inability to imagine that American industrial capacity and engineering capability could produce a fighter so superior that Japanese advantages in pilot quality and combat experience would prove insufficient. By April 1943, just 10 weeks after Walsh's division had destroyed 5 Zeros in their first engagement, 5 complete Marine squadrons operated Corsairs from bases scattered across the Solomon Islands theater. VMF-124 at Henderson Field on Guadalcanal, VMF-213 at Banneker in the Russell Islands, VMF-214 at Munda in New Georgia, VMF-221 at Turtle Bay, Espiritu Santo, and VMF-223 back at Henderson Field collectively fielded over 120 F4U fighters and approximately 140 trained pilots. These squadrons flew continuous operations, including combat air patrol, protecting American installations from Japanese bombing raids, close escort missions for Marine, Navy, and Army Air Force bombers attacking Japanese positions throughout the Solomon Islands, and offensive fighter sweeps deep into Japanese-controlled territory, seeking to destroy enemy aircraft either in the air or on the ground. The operational tempo was brutal, with individual pilots flying 2 or sometimes 3 missions daily during periods of intense operations. Aircraft maintenance crews worked around the clock in primitive conditions, often conducting major repairs in open-air revetments while Japanese bombers attacked overhead. But the results these squadrons achieved during April operations revealed the Corsair's true potential through statistics that would have seemed wildly optimistic just months earlier when the aircraft had been rejected for carrier operations. Marine Corsairs flying from Henderson Field and other bases across the Solomons claimed 60 Japanese aircraft destroyed in aerial combat during April 1943 alone. This represented 30% of all Japanese aircraft losses in the theater that month. Marine losses to enemy fighters during the same period totaled exactly 4 F4Us, 3 lost in combat, and 1 that crashed during an emergency landing after battle damage. This produced an extraordinary kill ratio of 15 Japanese aircraft destroyed for every American Corsair lost to enemy action, a ratio that exceeded any fighter aircraft in any theater of World War II and would have been dismissed as impossible propaganda if not for the meticulous documentation including gun camera film, witness statements from multiple pilots, and Japanese records captured after the war confirming the losses. Individual Marine pilots were achieving victory tallies in a matter of weeks that would have required months or years flying other aircraft in other theaters. First Lieutenant Robert Hansen of VMF 215, who would achieve 25 victories before being killed in action in February 1944, shot down 20 Japanese aircraft in his first 8 weeks of combat operations. Second Lieutenant Kenneth Walsh, whose first engagement had destroyed 2 Zeros, accumulated 11 confirmed victories by the end of April. These pilots weren't superhuman or possessed of skills beyond their contemporaries. They were competent, well-trained fighter pilots, flying an aircraft so superior to enemy opposition that their advantages in performance, firepower, and tactics translated directly into victory tallies that made them instant aces. These extraordinary results forced fundamental reassessment within both American and Japanese commands, though with completely opposite conclusions reflecting their different capabilities and strategic situations. American naval aviation leadership, initially skeptical about an aircraft the Navy's own test pilots had rejected for carrier operations, began recognizing that the Corsair represented not just an incremental improvement over Wildcats and Airacobras, but a revolutionary weapon system that could achieve and maintain absolute air superiority even when outnumbered. The Navy's earlier decision to relegate Corsairs to land-based Marine squadrons intended as temporary assignment until handling problems could be resolved had paradoxically created the ideal environment for developing combat tactics that fully exploited the aircraft's capabilities while minimizing its limitations. Marine pilots, given months of intensive training rather than the abbreviated carrier qualification courses, had mastered the Corsair's demanding handling characteristics. More importantly, they had learned through extensive mock combat exercises exactly how to employ energy tactics that leveraged the Corsair's superior speed, climb rate, and dive performance to negate zero maneuverability advantages completely. Their success provided a comprehensive tactical template that could be taught to new Corsair units deploying to the Pacific. Even more significantly, their combat results were forcing Navy leadership to reconsider whether the Corsair's carrier limitations were truly insurmountable or simply required different operating procedures and more extensive pilot training. Japanese command structure, conversely, struggled desperately to comprehend what was occurring in a manner that didn't undermine core assumptions about Japanese superiority and American weakness that had guided strategic planning since before Pearl Harbor. Individual combat reports arriving from surviving pilots consistently described similar disturbing patterns. American fighters that refused to engage in turning combat, where Japanese advantages could be exploited. Overwhelming firepower that destroyed aircraft with single bursts lasting only seconds. Speed advantages that allowed disengagement at will whenever Japanese fighters gained any tactical advantage. But institutional resistance to acknowledging American technological and industrial superiority ran deep in an organization whose entire worldview was built on beliefs about Japanese warrior spirit, compensating for material disadvantages. Senior officers had spent their entire careers in a military culture that emphasized spiritual strength over material factors. The idea that Americans, who Japanese propaganda consistently portrayed as weak, corrupted by luxury, and lacking fighting spirit, could produce weapons so superior that Japanese courage and skill couldn't overcome the gap, was literally incomprehensible within their cultural and institutional framework. The final tally speaks for itself. The Corsair ended the war with 2,216 enemy aircraft destroyed, achieved an 11-to-1 kill ratio, flew 64,000 combat sorties, and suffered a loss rate of just 0.7%. Japanese pilots learned too late that the ungainly bent-wing fighter they had mocked was actually the whistling death that would destroy Japanese air superiority forever. The sound of 650 caliber machine guns firing 1,200 rounds per minute had written the final chapter of Japanese naval aviation dominance. The transformation of Japanese attitudes toward the Corsair from mockery to terror occurred with remarkable speed, taking less than 4 months from first encounter to widespread recognition among Japanese pilots that this aircraft represented an existential threat to their survival. By May 1943, Japanese intelligence had compiled enough combat reports, interrogation statements from captured American pilots, and photographic reconnaissance of American airfields to understand exactly what they faced. The F4U Corsair was faster than any Japanese fighter by at least 60 miles per hour in level flight. It could dive faster than terminal velocity for Japanese aircraft. It climbed better above 15,000 feet. It possessed firepower that could destroy any Japanese aircraft with a single burst, and American pilots had learned tactics that exploited these advantages perfectly, refusing every type of engagement where Japanese aircraft had any compensating advantages. The assessment reached Admiral Koga's desk in early June 1943 and made for grim reading. Against Corsairs, Japanese fighter forces face disadvantages that cannot be overcome through pilot skill or tactical innovation. We recommend avoiding engagement when possible and developing new fighter types with improved performance. But developing new fighters required time and industrial capacity Japan simply didn't possess. The A6M50 variant, introduced in late 1943, offered marginal improvements in dive speed and engine power, but still couldn't match Corsair performance in any category except turning radius. The Kawanishi N1 KJ Shiden, potentially competitive with American fighters, entered service in small numbers far too late to affect the war's outcome. Japan's industrial infrastructure, already stretched to breaking point supplying ground and naval forces, couldn't produce advanced fighters in quantities sufficient to replace losses, let alone build up strength. Meanwhile, American production of Corsairs was accelerating. The Vought factory in Connecticut, initially producing aircraft at a rate of 1 per day, had scaled up to 5 per day by mid-1943. Additional production lines at Goodyear in Ohio and Brewster in Pennsylvania would soon add hundreds more aircraft per month. The industrial arithmetic was overwhelming. For every Corsair destroyed in combat, American factories produced 20 replacements. For every 0 destroyed, Japanese factories struggled to produce 1 replacement. The psychological impact on Japanese pilots of facing an apparently invincible opponent cannot be overstated. Men who had dominated Pacific skies with supreme confidence throughout 1942 now dreaded encounters with the bent-wing American fighters. The distinctive whistle the Corsair's wing made during high-speed dives caused by air rushing through the engine cooling slots became an auditory warning that sent shivers through even veteran Japanese pilots. They called it whistling death, a name that captured both the aircraft's most distinctive characteristic and the terror it inspired. Ground troops reported hearing that whistle and immediately seeking cover, knowing that 650 caliber machine guns would follow within seconds. Naval personnel described the sound as harbinger of destruction, a mechanical scream that meant American air superiority was absolute and Japanese forces were helpless targets. By August 1945, when Emperor Hirohito announced Japan's surrender, the Corsair had established itself as the most successful naval fighter in history. Final statistics compiled after the war told a story of complete dominance. 2,216 enemy aircraft destroyed in aerial combat represented more victories than all other U.S. Marine Corps fighter types combined. 64,000 combat sorties flown under every possible condition, from sea level to 40,000 feet, from equatorial heat to Arctic cold. A combat loss rate of 0.7% meant only one Corsair lost for every 143 sorties flown. This represented the lowest loss rate of any fighter aircraft in sustained combat operations. 122 pilots achieved ace status flying Corsairs, with the leading ace, Major Gregory Boyington, credited with 28 victories. These men and their aircraft had transformed American naval aviation from defensive force struggling to survive in 1942 to offensive weapon that achieved air supremacy throughout the Pacific by 1944. Japanese testimony to Corsair effectiveness came not from captured propaganda, but from the honest assessments of survivors who had faced this aircraft and lived to understand what it represented. Saburo Sakai, who survived the war despite being severely wounded and partially blinded in combat, wrote extensively about the Corsair in his post-war memoirs. "The F4U was simply the best fighter of the war," he stated without qualification. "Faster than the Zero in all speed ranges, better armed with those devastating machine guns, more rugged with armor that could absorb punishment, superior in climb rate above medium altitude. American pilots learned not to turn with us where we held advantage. They exploited their superiority in everything else. Against such tactics combined with such overwhelming performance advantage, we had no effective response. The few times we achieved victories against Corsairs, it was because the American pilot made a critical error or we achieved massive numerical superiority. In equal combat, the Corsair won every time." The final word belongs to the Japanese pilots who laughed that January morning when they first saw the ungainly bent-wing fighters climbing toward them. By June, those same pilots who survived were fleeing at the first sound of the Corsair's distinctive whistle. The transformation from mockery to terror, from confidence to despair, from air superiority to helpless inferiority had been written in the devastating firepower of 6 50-caliber machine guns firing 1,200 rounds per minute. The Corsair had not just defeated Japanese naval aviation, it had destroyed it so completely that by war's end, Japan's air forces existed only as scattered remnants incapable of effective resistance. The aircraft rejected by the Navy for carrier operations had become the weapon that secured American air dominance and helped drive Japan to surrender. That is the story of how Japanese pilots laughed at the F4U Corsair until 650 caliber Browning machine guns fired 1,200 rounds per minute, and the laughter died forever in Pacific skies.